Good morning, everybody. Today we're going to be talking about polar coordinates and how to sketch them. Um, and it should be pretty quick, but we'll see. Usually, when I say that, it sneaks up on us, and it's a little different. But polar coordinates are basically just a new way of writing the same type of coordinate, but uh, in a way that makes a little bit more sense after you talk about trig functions, because it looks a lot like angles, and it looks a lot like um, a unit circle type of situation. But we're used to drawing coordinates as Cartesian or rectangular coordinates. A polar coordinate, which has an x and y portion to the coordinate. So this is Cartesian or rectangular. So x and y. Polar coordinate has r and theta. R is the radius, and theta is the angle. Just like we've been talking about, we've been plotting a lot of Cartesian coordinates by having the radius being 1 and then the angle being whatever we need it to be. But essentially it's the same idea, and you can graph any coordinate as a rectangular coordinate or as a polar coordinate. Polar coordinates have some nice applications you can apply to them, but we'll get into those later. So just the idea behind a polar coordinate: you have the radius and you have the angle. The tricky part about the radius is that it can be negative, and a negative radius just means that you flip it over, you flip the ray over to the opposite direction. So it does matter if it's positive or negative, but we'll have an example of that in a second. So sketching 2 pi over 4. First, I start off by drawing the angle. So same, you're going to start here on our x-axis, and then our y-axis. Then we're going to do this, and you put an arrow at the end, even though really it stops right here. So you want to mark that you've gone out 2 units. This would be our r value and our theta. So that's pi over 4, this being 2. We have our angle here. Right, so we've been over this before, but 2 angles that land in the same spot, you can't really tell the difference once it's placed there. So you do have a lot of different angles that, a lot of different coordinates that will be in the same exact spot, which is a nice little application to this. You can come up with a full revolution plus pi over 4. So this would be 8 pi over 4, 9 pi over 4. So 9 pi over 4 is a coordinate. If I add another 8 pi over 4, and then we'll get into, again, we'll get to this in just a second, so might as well talk about it now. If I have 5 pi over 4, but I have a negative radius, it would then flip it over back over here. So we could say negative 2 5 pi over 4, negative 2 13 pi over 4. So lots of choices, really, when we get into these. All right, negative 2 5 pi over 4, we just did that. Basically, you're going to start off by drawing the angle. Kind of show your work throughout this process. So this is going to be 5 pi over 4. This coordinate is going to be 2 5 pi over 4. The only difference between 2 5 pi over 4 and negative 2 5 pi over 4 is that it gets reflected, and instead we're here. So this is -2, 5 pi over 4. The only difference is that negative angle. Okay. I'm going to do 5 pi over 3 down here. 5 pi over 3 is going to be over here. So we're going to draw the angle like so. And then we go 1, 2, 3. Put a dot there and label it 5 pi over 3. That's a 5. Okay, good. 2 negative pi over 4. Same idea. Go down. 1, 2. Draw your coordinate, and you're done. 3, 0. 3, 0 is on the x-axis. 1, 2, 3. It looks exactly like 3, 0 as a rectangular coordinate because the angle is 0, and so it's just on the x-axis. So that's an easy one. But then -3, negative pi over 3. Negative pi over 3 is right here. -3 being our radius, we'll flip it over. We go 1, 2, 3, and it's right there. All right, here's where it gets a little trickier here, just because we have to come up with satisfying the parameters that it's given to you. But we're gonna find other polar coordinates that match 4, 3 pi over 4, that have a positive radius and an angle that's between negative pi and 0. It would be helpful if we knew what this looked like first. So the standard would be right here. 1, 2, 3, 4, and we've got, so they just need to look like this in the end. So if we have a positive radius, basically we just need to come up with an angle that would land at the same spot as 3 pi over 4. It needs to be between -2 pi and 0. Easiest way to do this is to subtract 2 pi from 3 pi over 4. So 3 pi over 4 divided minus 2 pi would get us to -5 pi over 4. So we are going to basically graph for -5 pi over 4, which would be the same thing, just going the opposite direction. Actually, I don't think we need to sketch them, but if you wanted to, you could. All right, a negative radius, positive angle. With a negative radius, we know that we're going to need to flip it over. So the flipped position is here. So I need my angle to get here so that when I flip it, it lands back onto the correct location. These reference angles need to be the same. So pi over 4 is our reference angle. Basically 2 pi minus pi over 4 is going to get us to that spot. Then when we flip, we're in the correct spot. So -4 is our radius. We want it to be negative. And then we want 7 pi over 4 to get us to this position. Once we apply that negative radius, it gets us back. All right, radius is positive, so we're just going to use 4. 2 pi to 4 pi. We just need to add a full revolution to this. So we are working with 11 pi over 4. Not too bad. Again, these are just a new way of writing the same coordinates that you have been, but we're going to start getting into how we can use these and a few kind of stranger applications of these, but it starts to get into some weird math. So I'm excited. Hope you are. But until next time.